Hi, myself Thasa. My register number is URK24A1038. Today we are going to see about deep learning. In deep learning, we are going to see our first exercise called multi-class classification using a fully connected neural network. Now, here we have typed a code. That is, first we import TensorFlow as TF. This one TensorFlow is the main deep learning framework used to build and train a neural network. Then from TensorFlow Keras model, we have imported a sequential. Sequential helps us to create the model layer by layer. Then here from TensorFlow Keras layers, we have imported a dense flattened input. Dense is used to create a fully connected neural network layer. Then flatten converts the 2D images as a one-dimensional vector. Then input defines the input shape of our images. Then M MNIST provides the handwritten digit to categorical, which converts the numerical labels to one hot encoded vectors. Then matplot libas dot pyplot as PLT is used to display the images and prediction results. Then the second one is to load the data set. In this step, I load the MNIST dataset. It contains 60,000 training images and then 10,000 testing images. Each image has 28 pixel wide, then 28 pixel high. Then the grayscale. X underscore train contains training images, then Y train contains training labels. Then for X test contains testing images, then Y test contains testing labels. Then data normalization. Here, the original pixel values range from 0 to 255. Deep learning models works better when the input values are between 0 and 1. Then the next one is a hard encoding. The labels are originally numbers like 0, 1, 2, 3, 4 up to 9. The neural network cannot directly learn from these integers, so we convert them into a one hot encoding. For example, the digit becomes 0, 0, 0, 1, then all things become 0, then digit 7 becomes 1. This allows the neural network to correctly classify the digits. Then here we build a neural network. Since I use sequential, the layers are added one after another. Then here we are going to compile the model. Before training, we compile the model. Optimizer. It's use Adam Optimizer. It automatically adjusts the learning rate and helps the model learn efficiently. Last function here we use categorical cross entropy, since this is a multi-class classification problem. Then here we are training the model. Now the model starts learning. Training the model learns using the training images. We train for 10 epochs. One epoch means the model sees the complete training data set. Then the next one is evaluating the model. After training, we have to evaluate the model using a complete image. These testing images were never shown during the training. The model calculates as loss or accuracy. Finally, it prints the testing accuracy. Usually, the model achieves around 97% to 99% accuracy. Then, the ninth step is to making the predictions. Now, the model predicts the digit for every test images. The softmax layer returns probabilities. Argument max of function finds the highest probability, that becomes the prediction digit. Then here we are displaying the results. Finally, here it displays the prediction. It creates the figure of size 10 into 5. Using a loop, I display the first 10 test images. The hidden digit, the handwritten digit, the predicted value, and the actual value. If the both value matches, it means the prediction is correct. This helps the visually verify the model performance. Thank you.